All right, we're going to get started. I see a number of people have already joined. Hello, I am Laurel Ackerman from the AtScale marketing team, and I'd like to welcome all of you to today's Big Data Analytics webinar with AtScale and Ventana Research. Our presenters today will be Dave Menninger, SVP and Research Director at Ventana Research, and AtScale's founder and Chief Strategy Officer, Dave Mariani. I'm going to go over just a short list of housekeeping items before we begin. Today's webinar will run for about 45 minutes, and we'll have time at the end for Q&A. You should see the Q&A feature at the bottom of your Zoom screen. Please use that to send over any questions that you have during the webinar. We'll hold them all for the end. We may not have time to get through all of them, but we are taking note of them. Please note, and we'll make sure that when we follow up with you, we'll get you the information that you need. The recording for this webinar will be available after this live event, either later today or first thing tomorrow. We will email it out to all of you, and you will also be able to find it on atscale.com. So let's get started. I'm going to hand this over to our presenters, Dave Menninger and Dave Mariani.
Thanks, Laurel. So we've got our background up on the screen. We're not going to walk you through the introduction there. You can refer to that later. And what we'll talk about today is, why big data is valuable and some of the trends that we see around cloud, obviously becoming an inevitable part of big data scenarios. We'll talk about some of the reasons why. We'll look at some of the challenges. We'll conduct a couple polls while we're talking with you today, and then offer some solutions to how you create valuable big data systems in this world of distributed and diverse data. We'll look at what an architecture might look like involving big data analytics, and talk about a little bit of the trends we see for the future. And then we'll wrap up with some Q&A. So let's get started. So I'd like to start with why we think big data is valuable. You may have this opinion already, but I think there are a number of trends that are driving the reasons that big data is valuable. And fundamentally, the economics have changed. They've changed dramatically, making it much more valuable, and the economics continue to improve. The cost of computing and storage have declined so significantly that we can basically store and analyze all the information that we collect. Beyond Moore's law of increasing computing power, we see scale out and distributed systems, whether they're cloud-based or on-premises, as one of the reasons for the dramatic decline in costs. I also think that you can say that Hadoop and now object stores are another reason for a dramatic decline in costs, reducing or eliminating, in some cases, database license fees. And with the decline in computing costs and increase in computing power, we're now able to perform much more sophisticated analyses, such as artificial intelligence and machine learning, which increase the value of the data that we collect. So what's the role of big data in modernizing analytics? Analytics are now conducted at a much more granular level than ever before, because we can capture, save, and analyze so much more data. As a result, organizations are using more data in more ways to get a leg up on their competition. And in fact, our research shows that the #1 benefit of big data is gaining a competitive advantage. So you'll see here a chart and just an explanation of how some of these charts work. When you see bars, it's because people can select more than one, and therefore the responses can add up to more than 100. If you see a pie chart, then they can only select one of the responses, and the answers will add up to 100%. So you see here that gaining a competitive advantage was the most frequently cited benefit that organizations reported, but they also indicate that they're lowering costs, they're improving customer experience, they're responding faster to opportunities in the market, and they're increasing sales. So these are all pretty significant benefits. And you can use big data to understand your customers and your operations in such detail that you can optimize your interactions with those customers and improve the efficiency of your organization's activities. And the benefits of modernizing big data and analytics are being realized across the organization. Customer service organizations are modernizing analytics to determine the best and fastest resolution to customer service requests. Sales organizations are better able to assess which opportunities in the pipeline are most likely to close and which sales personnel are most likely to meet their quotas. Marketing organizations are delivering more effective campaigns for the company's products and services. Procurement departments are evaluating suppliers based on not just cost per unit, but also product quality, lifetime warranty claims, and on-time performance of the vendor. And human resource departments are using big data and analytics to determine which candidates to interview, which ones to hire, and how to retain members of the workforce. Here's what our research shows about which functions are most likely to be using big data as part of their modern analytics efforts. Generally, it's front office, revenue producing functions, marketing, customer service, and sales, those kinds of functions. They tend to be at the top of the list in addition to finance. One of the reasons I think that's the case is that there's generally an unlimited upside potential. Unless you've dominated your market, there's more upside potential than decreasing your costs. Your costs can only decrease so far, but unless you've got a monopoly, you can probably continue to increase your revenues. So let's do a quick poll to see what your expectations are regarding big data analytics. Laurel, you want to conduct the poll? So if you could take a moment and answer the poll on the screen here. It's just one choice, one question. What benefits do you expect to gain by modernizing your big data analytics? And obviously this will be driven by what part of the organization you're in, but just a quick sense of where our audience is seeing the opportunity for benefits today. All right, that's probably enough time. Laurel, why don't we put up the results? Okay, so it looks like better information sharing is the most common response. And we see that frequently in a lot of the analytics research that we do. Analytics helps people share information in an organization, and the information becomes more consistent. But we see, a number of other benefits as well. The next most significant, it looks like, is driving business results and revenue. So some of the same things that we saw in the chart that I had put up there, some similar patterns in the responses here among the audience. So I'm going to go ahead and close the poll. And Laurel, can you tell me, is the slide showing now? Hopefully we see the slide.
Looks good. Looks good,
yes.
Dave.
Yep.
Okay, good. So let's continue. The cloud is inevitable. So you've probably all got some business operations in the cloud, some of your activities going on in the cloud. Let me share with you some of the research that we see from our research that we've conducted. So we see that 86% of organizations expect the majority of their data to be in the cloud at some point in the future. And we see it in all the different types of research that we do, but this is just one area in which we've seen significant penetration of the cloud. Another one relates to doing analytics. So nearly everybody, 99% of the participants in our research, expect to do analytics in the cloud at some point in the future. In fact, half of them are already doing some analytics in the cloud today. So significant presence of analytics in the cloud. When we look at the sources of data used in analyses, cloud business applications are the most common external source of information that organizations utilize. You might debate whether or not you consider cloud business applications external, right? I mean, if you're using Salesforce, is that an external application or not? But in the context of this, we treated that as an external source of information. And why are people interested in the cloud? What makes it so popular? Basically, it makes things easier. 1/3 of participants in our data lake research have adopted data lake platform in the cloud as their primary data lake platform. And early results from some of the research that we're currently conducting suggest that as much as 1/2 of all big data implementations are done in the cloud. These results aren't fully baked yet, but that's what it's looking like. And by the way, if I could take a moment to encourage you to participate in our ongoing big data research, I'd appreciate that. We could use as many responses as possible and make sure that your views are represented in the research that we're conducting. So why are so many people implementing their big data solutions in the cloud? Well, big data systems typically require many nodes, potentially hundreds or even thousands. Installing and managing those nodes can be difficult. Whereas if you utilize the cloud, you can offload all of the installation and the maintenance onto the cloud provider. If you license software as a service, you can even offload the software installation and maintenance too. The net effect is that you can focus on applying big data analytics to your business processes rather than doing hardware and software maintenance and administration. You can also get started faster. You can literally turn the system on and have a large cluster available within minutes. You can also expand and contract as necessary. That's harder to do if you have to order new equipment and stand it up on premises, install the appropriate software. What do you do when you want to contract your configuration if you've purchased the hardware? Do you list it on Craigslist so that you can try and sell some of it? All right, that's a little dramatic. You're probably using virtualized systems in-house as well to mimic the cloud to some extent, and that's fine. The point isn't whether you're using public or private cloud resources. Both make big data much easier. So Dave, how do you see the cloud impacting your customers?
Yeah, Dave. So first of all, just within our own customer base, I just did a quick check, and over 3/4 of our customers are either have moved to the cloud or in the process of moving to the cloud, or have the intention to move to the cloud within the next 3 months. So and a lot of our customers are from the types of verticals that you wouldn't think would be first movers to the cloud. That's financial services and healthcare. So definitely lots of motion there. And everybody's looking to the cloud for the reasons that you just laid out, to get agility and to be able to access more data quickly. So I thought I would just put in here and talk about a few use cases with specific customers of AtScale and what their journey was to the cloud. The first is a retailer. It's a well-known home improvement retailer, and they were able to move really multiple times in terms of data platforms. So it wasn't that long ago when everybody thought that Hadoop was going to be the end all, and it turned out that Hadoop was just one kind of data platform for specific types of workloads. And so what we've seen is that we've seen data platforms come and go, and we've seen the landscape become much more complicated when it comes to data platforms. So with this particular retailer, they first modernized their analytics infrastructure by moving from SQL Server Analysis Services to AtScale on Hadoop to get the same capabilities and to keep all their 3,000 store users with access to multidimensional data using Excel with a live direct connection. So that was the first migration from Hadoop, from an on-prem database to Hadoop on-prem. They then flipped the switch to Google BigQuery. So why did they move to the cloud? For a lot of the reasons David just laid out. Too hard to manage that infrastructure. Took too much effort to be able to manage that on-prem cluster, and they moved to the cloud to get that agility, and then to introduce new applications, including a new application for their partners. That's their vendors and their suppliers. And so those suppliers now, 9,000 of them, can get access to SKU level data all in Google BigQuery through AtScale. And be able to manage their inventory across all their stores across the nation. So if you go to the next one, David. This is another example again, a very well-known food processor, household brand. And in their case, they moved from Teradata to the cloud. And they moved to two different clouds. Why? Because one of their major retailers where their product sells is Walmart. Walmart is in a Google cloud, and they had chosen for the rest of their operations to go to Amazon and Redshift. So with AtScale, they were able to operate in two different clouds, all transparently to those users who were actually doing analytics, 21,000 queries a day. And those queries are very fast, 10 seconds or less. And so all those users were able to manage that inventory, manage those sales across those different, retail stores of their partners, all with data in different clouds, all with direct syncs with Walmart data, all transparently, regardless of where it was, whether it started on-prem in Teradata, whether it moved to the cloud, whether it moved to multi-clouds. They had that single semantic layer that allowed them to fire at all cylinders. Back to you, Dave.
Thanks, Dave. Let's talk a little bit about some of the challenges that we see. I mean, it's not all a bed of roses. You know, there are challenges in working with big data. So some of the things we see is that, you know, modern analytics includes access to a wide variety of data sources. Data models can be complicated for line of business personnel, even when they're confined to a single department or domain. But big data often spans multiple domains. It's not, you know, restricted to just one area, has many levels of detail, and it makes the data models even more difficult to understand for the line of business personnel. So performance can also be a challenge. As data volumes increase, the performance of many analyses decrease. The line of business personnel become discouraged when their analyses take longer, and as a result, they're less likely to fully explore the data. I mean, think about, you know, the interactivity of working in a spreadsheet with a modest amount of data. That's really what people expect, regardless of the amount of data that they're working with. You know, there's only so many hours in the day, and if the analyses take too long, you can't explore all the different scenarios, and you just start to become discouraged and don't even want to explore other scenarios. Another challenge is finding the right data. You know, given the increased volume of data and the number of data sources, how are line of business personnel supposed to find the specific information that they need for their analyses? And how do they know whether the sources they've found are approved or sanctioned for use within the organization? I mean, it gets pretty complicated. And then there's the issue of cost. You know, we said that cloud makes things easier, but one area that's more difficult is in you know, projecting the costs of utilizing the cloud. It's not like a fixed cost where you've invested in the information or the capital, and so you've got this variable cost that's harder to predict. Another challenge is that it isn't just one cloud, as Dave mentioned, right? You've got multiple clouds out there, and organizations are starting to use more of those clouds, and very few organizations operate entirely in the cloud. So here's some of our research that talks about, you know, where data lives and where it goes to in the process of preparing it for analysis. Only about 1/4, 28%, is purely cloud to cloud. You know, yes, there will be some organizations that operate entirely in the cloud, but that tends to be the exception rather than the rule. You know, you've got to look at the on-premises to on-premises scenarios and the, you know, on-premise to cloud, cloud to on-premise. Those are all significant parts of most organizations' analytical processes. So you need to consider how this is going to impact your organization. It's not all going to be in one location. So let's do a quick poll, see if that surprise cloud bill issue affects your organization. So have you been hit with an unexpected bill for your cloud database usage? You know, as we said, you know, It's not necessarily, now you may have different types of pricing models, right? Depending upon what pricing model you use, you may not have as many surprises, but let's see how often our attendees today are encountering surprise cloud bills. So it's a pretty simple yes, no question. That's probably enough time, Laurel. Let's go ahead and close the poll and see the results. So about two-thirds of you have seen an unexpected bill from your cloud database usage. So from my perspective, that's not really surprising. And we've seen that often in the organizations that we deal with in our research processes. So Dave, you've got some information about some benchmarks and costs. You want to go over that information for us?
Yeah, so I can tell you that I couldn't vote in that poll because I'm a presenter, but I definitely got surprised and got in a lot of trouble from my CFO, especially when I was running this benchmark. So these numbers that you're seeing here are actually, for the next two slides, come from a benchmark that AtScale did on TPC-DS. That's a very popular decision support sample data set by the TPC organization. We did it on 10 terabytes. So a representative set, that's about 280 billion rows in the biggest fact table, 65 million rows in the biggest customer or dimension table. So pretty decent size stuff. And in this test, we ran through a set of TPC-DS queries, and we ran through it, and this is the results of the cost. And you see in this graph is that you can actually see this is for Google BigQuery. And so for running the test, just for those tests, and this is for 20 queries, 20 queries along different loads for user concurrency is a huge difference in the pricing models. So what you see here on the red is the on-demand pricing model. And what you see here on the left in the green is the fixed rate pricing model. So herein lies the rub. The on-demand pricing model is you're paying for every amount of data read. So it's based on the number of bytes scanned per each query. Now you can imagine that that's not very easy to predict, especially when you have customers, your customers or end users running ad hoc interactive queries. They could end up scanning much more data than they expected. And that's going to end up going right down to the bill. And you're probably not going to see that until the end of the month. So you wouldn't even necessarily even known that you were generating those high costs. Now, the alternative is to go for a fixed pricing model, but that's not trivial either, because in order to get the on-demand compute that you see here, it's actually, it actually is 2,000 slots in Google BigQuery speak. And each 500 slots is 10K per month. So that would be 40K on $40,000 a month to get fixed rate pricing on that that level of load. So it's not obvious, it's not trivial, and my advice to you is to run the numbers, look at your workloads, and make sure that you got it covered in terms of predicting or trying to predict what your costs are. And AtScale can help you on that. So David, if you go to the next slide, this is an example really of user concurrency in the cloud, something else to really be mindful of. So what you see in this graph is that there's graphs with the red is with Snowflake, and Snowflake running 5 user concurrent queries, 25 concurrent queries, and 50 concurrent queries. And what you're seeing here is the total amount of minutes that it takes to run that TPCS 20 query data set for each of these sets of users. Now, what you're seeing here is you're seeing pretty much linear scale. In other words, the 25 is about 5 times longer than the 5, and the 50 is about twice as long as the 25. That's actually not what you want to see. What you want to see is that as you add more users, you don't want to see your performance drop commensurately. And with AtScale, you can see the amount of time it took with AtScale on those same queries across the different users. It's obviously multiple times faster, but also you can see that there isn't that linear jump in concurrency. So those are sort of the two takeaways. And if you want to learn more about not just Snowflake or Google BigQuery, but also Redshift, you can come to our website and download our reports for each to see how to see what the results were. So David, if you can go to one more slide here, we can talk about a specific customer here. So this is a major online retailer based in Europe. In this particular case, this customer saved $10 million a year on Google BigQuery costs with AtScale. How do they save $10 million a year? Just like if you look at that first slide, they do on-demand pricing. And because of our ability to be smart about caching and creating aggregates, we avoid scanning that data. We avoid rescanning data over and over again, which helps you with user concurrency and obviously lowers costs for Google by a factor of 10x. So not only is it lower cost, it's also super fast, 98% of the queries in 1 second, all done with pretty good scale, 70,000 queries, analytical queries per day for this particular retailer. So back to you, David.
Thanks, Dave. So, we've talked about the value of big data. We've talked about some of the challenges. Let's talk about what some of the components are to the solutions of taking advantage of these types of systems. I think one of the first challenges and one of the first things you need to address is how do you make data access easier? We talked about the complexities of all the volumes of data, the types of information that are managed. And when you're trying to get performance out of a large system, from a technical standpoint, you may be structuring things in ways that make it even more complicated for the users to understand. So if you can provide some sort of a semantic model that's understood by the line of business, you then provide an access mechanism for the line of business users. You provide a map, if you will, a mental map of the data, and you provide it in a format that typically is consistent with or familiar to the line of business personnel. Another suggestion in terms of making data access easier is that I suggest that you consider some data virtualization to provide access to some of the diverse data sources. Yes, there's a trend toward implementing data lakes, but I would still say that it's rare that an organization has all of its data in one single consolidated place. They may even have multiple data lakes, but even if they have a data lake, there's some amount of information that's typically in a separate system. I alluded to external systems before. So by default, you might think, okay, well, I need to take that external information and load it into the big data system. But the alternative would be to provide virtualized access to that information. You don't necessarily have to get that information and physically load it if you can access it in place and reference it as part of this semantic model. So that's a way to extend the big data analysis to incorporate sets of information without necessarily modifying or loading the information into the system. You need to make it faster. Sure, distributed systems with parallel processing are one way to do that. You want to have more nodes, more CPUs. You want to have more, in the case of spinning disk, you want to have more, spinning disks happening simultaneously. So all those things help with speeding the processing up. But that doesn't necessarily solve the problem. The systems do improve performance, but there's still plenty of opportunities for accelerating that performance even further using things like caching, using things like pre-aggregating information, using things like materialized views. And generally, these things are predicated on understanding the pattern of usage of the information, right? It doesn't make sense to pre-aggregate things that are only accessed once in a while. It's better to utilize that capability for information that's accessed frequently. So generally, these accelerators include understanding and viewing how information is used, and then constructing those accelerators specifically to match the usage patterns in the data. And then, Dave alluded to a customer scenario that's happening more and more frequently. The information is going to span both on-premises, hybrid type scenarios, and increasingly the hybrid scenario involves multi-cloud, not just a single cloud vendor. So if you can create a single data fabric that spans all of those are ways to make the big data much more usable. So we talked about virtualized access, and so here's some research that we have. You want to be able to bring this information together, and one of the ways to do that is with data virtualization. The data may appear as if it's local, but it actually continues to sit and reside in the source system. And our research shows that 1/4 of organizations that participate in our data lake research are already providing data virtualization, and nearly 50% plan to include it as a future capability in their data lake. So just about 3/4 of organizations either include or plan to include data virtualization. Now, one of the questions is, how sophisticated is your virtualized access? Does it deliver adequate performance? We talked about how important performance was. For example, is the system caching the results of prior queries from these, I'll call them external sources? And does it know when those caches have become invalid, right? Is there intelligence about how joins are performed, right? There are different ways to join information from external systems. Do you move data around to try to accelerate some of those joins, or do you just bring data together in regardless of its size? So there's a lot of things you can do, and I would say today many virtualized data access systems are relatively simplistic. They're somewhat like the external table scenario. But in the big data scenario, that's really going to bog down pretty quickly from a performance perspective. So, let's talk about what a modernized big data architecture might look like, what some of the components are. Here's a marketecture slide of what I believe is required. I mean, fundamentally, what we're trying to do is get from raw data, which in my opinion, includes source data that may not really be raw, all the way through to analytics that help improve business processes. The point here isn't, to break down the various types of analytics in this architecture slide. It's rather to look at the elements that are needed to deliver in the data portion of the stack to make the data ready for analytics. So let's start from the bottom up. To achieve any kind of scalability, I suggest you need a distributed data management system, as we talked about. That might include relational technology, it might include Hadoop or NoSQL, might include object stores, but to achieve scalability, it's got to be distributed. We've already discussed data virtualization. I think that's a great way to supplement the distributed data management system. And architecturally, I may not have drawn this exactly correct. Typically, the data virtualization layer will sit over or under, the distributed data management system. So you're presented with one view of the information. The next step in the process is that you need to provide that performance and acceleration layer that we were talking about earlier. Managing the cache, managing aggregations, creating materialized views, or any other acceleration techniques that might be necessary. Those things can all be managed and hidden from the users, and then presented to the users in a logical business model, something that they can understand, and a format that they're familiar with. They don't need to know the physical structures. And in fact, if they do know the physical structures, it probably makes it more complicated for them. But you do need those physical structures to have efficient storage and to accelerate the performance. And that logical layer needs to present information to the analytical tools that the organization uses. And they probably have more than one. So you can't necessarily make that logical data model part of the analytical tool. It needs to be independent of it so that it can feed the multiple tools that organizations use. And all of these things need to be supported by, governance and security, see on the left, and they need to be available across the hybrid of on-premises and multi-cloud deployment. So, from an abstract point of view, those are the kinds of pieces that I see are necessary in this scenario. So let me ask Dave to talk about their architecture and how they deliver fast analytics on big data.
Yeah, thanks, Dave. And this is how we do it. So a lot of the components, well, all of the components that you saw there are in that AtScale layer that's in between here. So what we've done is that we've really built a virtualization platform for analytics specifically. So not only are we going to connect data, whether it's in the clouds or in multiple clouds, whether it's on-prem or whether it's even in other SaaS applications that are hosted by other people's clouds. The point is that the consumers of that data, whether it be BI tools or whether it be data scientists with their ML and AI platforms, are going to see the same common view of data. It's going to be performant and through our caching and performance accelerators. It's going to be governed. So everybody, regardless of the tool they're using or their use case, are going to get access to the same data and see the same data elements with the same security, regardless of their method of acquiring that data. So and behind the scenes, you have a truly first-rate business intelligence engine that is going to add value on top of the data without having to move it or to suck it in or pre-materialize it. So if you hit the next slide there, David, for us. With that sort of virtualization, what you get is you get some really tangible benefits here. So besides the fact that you have your governance layer now, where you have every query being secured and governed by the same rules, besides the fact that now you have a semantic layer where everybody's going to be speaking the same language, you get also the added benefits of query performance. So again, these come from the Cloud Data Benchmark. We reported performance with AtScale 61 times faster. 61 times faster for a set of TPC DS queries than without AtScale. And like I mentioned before, we saved 10x the cost of the cloud, which means that you obviously can drive a lot more value for your dollar and cover a lot more use cases, as well as introduce that capability to much more users without having the costs that come with that additional load. And really, with that semantic layer, rather than forcing your users to only write SQL and use SQL, they have now a semantic layer that's much more simple and 76% simple by our calculations of looking before and after AtScale SQL against a semantic model versus raw SQL that users would have to write. So again, these numbers are all detailed in our benchmark report that's available for you to access. So David, if you hit the next slide. This is very similar to what David showed. This is, and if I was, I ran analytics for and data pipelines for Yahoo back in the day. This was back 2010, before we were using the word big data. And so I had really had a choice of Oracle and Oracle RAC, and that was my data warehouse. I was fortunate enough to be at Yahoo when we invented Hadoop. So this whole new data lake concept was something that was fascinating, and we were inventing at the time. So with the advent of the cloud, that data lake now is in the cloud. And so starting from the bottom, and this is where really AtScale sits in the ecosystem, is that what I see most customers doing, and what I would do if I were building a new analytics stack, is I would start with and land all my data in the cloud data lake, meaning in the file system. If I'm on Amazon, that's S3. If I'm in Azure, it's ADLS. If I'm in Google, the Google Cloud, it's Google Cloud Storage. So by landing all the data there as is, no transformation, I can then decide how I want to consume it. So if I want to consume it for financial reporting where I need clean data, I might still do a traditional data pipeline and then land it in a cloud data warehouse like Snowflake or Redshift or BigQuery. I may feed and feed that raw data that's in that data lake straight to my AI systems, so that they can build their models off of raw granular data. Or I may want to even consume and do ad hoc exploratory analysis straight on that data through tools like Tableau and Microsoft Power BI. And then along the way, I have my data catalogs like Calibra and Elation, who are actually creating policies. So I want to be able to apply those policies across the stack from data lake to the actual consumption layer, where AtScale can actually integrate with those data catalogs to enforce those policies. So the AtScale engine and the AtScale engine really sits as that go-between, so that we can deliver one semantic view of that data, regardless of whether it's in a data warehouse or it's in a data lake or it's in any other sort of data store that is under the management of that enterprise. And at the same time, govern every single query, whether it's being consumed by AI, BI, or even custom applications. So that's really where AtScale fits in the ecosystem and where we provide value. So back to you, Dave. Oh, one more. So just to summarize, and then we'll stop the AtScale commercial. These are some of the other key benefits that you get with AtScale. Of course, there's no data movement, so there's no more data latency, no more creating data extracts. There's no compromise by getting rid of pre-aggregation. It means you can do what that retailer did, that home improvement retailer did, which is access data at the SKU level for their suppliers. You can get rid of all that extra unneeded ETL and only do ETL when it's absolutely necessary. So you get rid of the complexity of data movement and the cost associated with it. You get to be able to do multidimensional analysis in addition to just flat tabular analysis, but on the same data with the same governance. You obviously increase scale and concurrency, as we've shown, as well as reducing cost. And all that comes with when you don't move data and you leave it where it is, you improve your agility and your ability to combine data sets without doing any kind of physical data engineering. Okay, now back to you, David.
Thanks, Dave. So let's talk about a few of the future trends that we think are on the horizon. We've talked about one of the biggest trends, increasing adoption of cloud object stores. In that same research that I referenced that's in process right now, we're seeing a very large increase in the usage of cloud object stores as one of the underpinnings for big data systems. And in general, we've seen increasing adoption of cloud databases and cloud deployments, right? The Snowflakes and the Redshifts and even the traditional vendors are moving their products to the cloud. So we expect to continue to see much more adoption of cloud-based distributed database systems. As the research indicated, I think we'll see increased data virtualization. And I think that's becoming more accepted and more of an inevitability in the sense that, we tried for years, maybe even decades, to have all our information in one place. And for governance reasons and other reasons, I think we're increasingly accepting the fact, and also because we have technology that now may enable us to leave data in place, we're accepting the fact that it's going to be in multiple locations and we need a way to bring all that information together. Our research shows a pretty steady variety of database usage in organizations. We think that will continue. Sure, relational databases dominate the landscape, But we've seen very consistent use of NoSQL databases, in-memory databases, and other ways, I'll say, to supplement or extend the relational database world. Dave mentioned data catalogs. Unfortunately, we think that at least for the near term, there's going to be a proliferation of data catalogs. Everybody's recognizing the value of data catalogs, and we think that there will be more and more of them. Your analytics tool is going to have a data catalog. Your big data system is going to have a catalog. You might have an independent catalog, to help you search through the information across all these different sources. So there will be some challenges around bringing all the information together in those various catalogs. But ultimately, I think, in the end, having that information available will be a net positive for organizations, but there are some challenges to work through there. We do think we'll see lower latency become a requirement. If you think back to when, I'll say, big data first came on the scene, if we sort of consider Hadoop as representing the start of the big data trend, Hadoop was not a real-time type of system. It was batch analyses. Over time, we've seen MapReduce replaced with things like Spark, and we're seeing lower and lower latency requirements even among big data systems. And so we expect that trend will continue. In fact, I have a theory that data will be considered to be in motion first, and it'll be data at rest after the fact. We'll switch our primary view of data to being data in motion, not data at rest. Not that data at rest will go away, just that we'll think of it first as data in motion. I also think there'll be more use of AI and ML. We've researched this extensively in other parts of our research, and organizations are still challenged with skills and resources, governance issues, related to artificial intelligence and machine learning. So we're certainly using it, but we'll tackle more of these challenges and see more and more usage around AI and machine learning in conjunction with big data. So what we've tried to walk through today is explaining some of how big data is valuable, show you some of the research related to that. Big data is inevitable. It's inevitable it's going to be in the cloud as well. It's too complicated to manage all these systems on premises. When you reach the point, you may reach the point where you're consuming enough cloud resources that economically it makes sense to bring it back on premises, but certainly to start, it's a lot easier to do it that way. And then, big data can be challenging. We talked about what some of those challenges are, and hopefully gave you some ideas about how to tackle some of those challenges. And, Dave Mariani has tried to tell you how this is achievable with, the AtScale solution. And generally, if you can deploy an architecture like this, it's a way to deal with some of those challenges. So at this point, I'd like to turn it over to Laurel to lead us through the Q&A. And Laurel, over to you.
Thank you, Dave and Dave. We actually have some great questions. We probably have time to address a couple of them. The first one being, what are the demographics behind your research, Dave?
Oh, sure. So we generally target, now it varies from study to study, but on average, we tend to see about 75% of the respondents from North America and 25% from rest of the world. So, it does have a worldwide base to it, but it is more, more populated with responses from North America. We, deliberately try to get a distribution of different company sizes, and no one company size really dominates. I would say that, the bulk are probably in the range of $100 million in revenue to $1 billion in revenue, but there's good representation of larger and smaller companies as well. The industries, cross industries, probably manufacturing and the services sector being the largest, but we do have representation in financial services as well, and probably the smallest representation is among public sector and education. So, we try to make it as diverse as possible. It's a pretty broad cross-section of organizations.
Great. Thank you for that dive into your research base. And then here's another question. Why can't we just rely on our BI tool vendor to bring the data together and provide high performance?
So, I mean, my opinion, Dave can jump in here too, but my opinion is that there's a couple of issues. First of all, I mentioned your organization is likely to have more than one BI tool. So, you might spend a lot of time and effort making one BI tool perform at scale, and then you have to repeat that work, probably do it differently in another tool to make that tool work. So, if you can do it in some sort of consolidated fashion, that's a better solution to try and solve this problem. If you look back at that architecture diagram I had up earlier, I suggested that layer ought to be independent of the analytics tools and applications. The other part of the problem is that the BI tools were not really designed, the BI tools that we have in the market today were not really designed to work with big data. Generally, maybe an oversimplification, but generally they're designed to leverage in-memory structures to achieve performance. And those in-memory structures are obviously limited by the amount of memory that you have. So there's some challenges there. Perhaps your data will fit in memory. The memory capacity has continually increased, and so perhaps your organization's data can fit in memory. But if you're really operating at huge scales, you're not going to fit all your data in memory. And so the BI tools generally have a solution to operate on big data, but it's not the same as their really high performance in-memory solution. So those are a couple reasons I suggest. I don't know if you want to offer any additional comments, Dave.
Yeah, so I like, first and foremost is your first point, which is that, look, we live in a multi-BI tool and multi-AI tool environment. So you have to perform that optimization for each one of those tools. And then the second part is that each of those tools are trying to keep you in their ecosystem. And that means if you're in Tableau, you're creating a Tableau data extract. And if in Power BI, you're importing data into Power BI, which is essentially embedded SQL Server analysis services. And so all that data movement creates complexity. So it's just, which means it creates latency, which we have to make compromises, which means you can't get the visibility into the atomic data that you may need to answer a question. And then you're relying on IT to hand you those extracts and to manage those. So besides the fact that it's just like it's a multi-user world, it also creates complexity, latency, cost, all the things that that we're trying to avoid to begin with.
All right, thank you both for that answer. We have time for just one more. Dave Mariani, I think this is best for you. There's a question from someone in the audience about who the biggest finance clients who actually implemented AtScale are.
Yeah. So, I mentioned that financial services and healthcare are two real, and retail are three really large verticals for us. So on the financial services side, we have customers like the major money center banks, Wells Fargo, Chase, and big credit card processors like Visa. Are some of the big customers. US Bank and TD Bank and Bloomberg are some of the big sort of financial services customers. And on the healthcare side, it's like everybody that you probably know. It's the Blue Cross, the Cignas, the Aetnas, and then the pharmaceutical guys like United Healthcare's and the pharmaceutical guys like AbbVie and Biogen. So lots of people with big data, with sensitive data, who need access, who need governed access, but they need to be able to use data to drive their businesses. Healthcare in the past, in my first generation, healthcare was always a laggard when it came to data warehousing. And what we're seeing now is just the opposite. Healthcare is on the forefront. and financial services was always on the forefront and continues to be.
Great, thank you. Unfortunately, that is all the time we have today, so we need to wrap this up. Dave Mariani and Dave Menninger, thank you so much for this great conversation. As mentioned, we will be sending out a link to the recording as soon as it's available in the next day or so to everyone who signed up for this webinar. So thank you everybody for joining us today.